Okay, let's start by solving using any method. Now you can use substitution, elimination, or you can use graphing. In this case, if you want to use substitution, substitution calls for having one or the other equation being in an x equals or a y equals form. And even if they're not, if you can make that happen relatively quickly, substitution would be a good method. I could see that being used here. But elimination also works when you have a chance to, when you have x's and y's equaling a constant, x's and y's equaling a constant, and if you can get the x's and the y's to somehow cancel, then you can eliminate a variable. In this case, it's not perfectly set up for that to happen, but if I multiply through one or the other equation, I can make it happen. Okay? For instance, if I just take this first equation, I multiply everything by 7, I'm left with 7x minus 14y equals negative 70. Okay? That's if I take and I multiply that first equation by 7. So I'm going to kind of lightly scribble this one out. I'll leave it in case you want to go back to it. But now my equation becomes this. And I can do elimination because when I add down, these cancel. And now I just have negative 15y's, that's negative 1 minus 14. And over here I have negative 75. I divide each side by negative 15. And y equals 5. Okay? Now remember, with any system, meaning two equations, my answer is always in an xy ordered pair form. Remember when you do graphing, if you solve it by graphing, you're looking for where the two lines cross each other. That would be an intersection point. So now I'm going to take this y equals 5 and I got to plug it back in. I can plug it back into either one. Let's say I plug it back in here to the first one. I have negative 7x minus 5 equals negative 5. So negative 7x equals, let's see, if I add 5 to both sides, I get 0. So x equals 0. So my ordered pair is 0, 5. Okay? I'll go back here and just draw in this step in case you were wondering what I did there. Added 5, and then divided each side by negative 7. Next example, let's solve by completing the square. Okay, so completing the square. Basically, you want to leave this part here. I'm going to add this, move it over here, so that I have a blank space here to complete the square. Now, when I complete the square, I have to do it to both sides. How do I know what completes the square? I take the middle number, negative 4, I cut it in half, which would be negative 2, and then I square it. And negative 2 squared is a positive 4. Positive 4. I do that to both sides. The reason I do that to both sides is that now I can write this left side as, if I factor it, it factors to r minus 2, which is the same thing as saying r minus 2 squared. Okay? On this side I have 12. Now to finish this, I undo a squared by taking the square root of each side. So on the left side, the square and the square root cancel. On the right side, I have the square root of 12. Well, if you think of taking the square root of 12 and doing a factor tree, that's 4 times 3. 4 is 2 times 2. And remember, in order to break out from under a radical, you have to pair up. One breaks out, one gets knocked off. So the 2 breaks out from under the radical. The other 2 gets knocked off. This 3 is stuck under the radical. Okay? To finish this, I add 2 to both sides. and r is going to be 2 radical 3 almost forgot my plus or minus. Whoa, that was almost a big time mistake. Let's see here, square root of plus or minus. Positive or negative, so this is positive or negative 2 radical 3 plus 2. Or you may have, at other points, let me go down here. Other times we wrote this as 2 plus or minus 2 radical 3. That's probably the better way to write it. That's the correct way, I'd say, to write a complex number. So let me just kind of go up here. I'm going to erase that. And let's go with 2 plus or minus 2 radical 3. Okay. Another completing the square. I know you guys need to practice. I know this was one of the things that we had, it was tough getting used to. I'm going to subtract the 37. So I have m squared minus 4m. I'm leaving this open space so that I can put something in that will enable me to complete the square. Well, this is kind of the same as the last one in that if I take negative 4, I cut it in half, then I square it, that gives me a positive 4. And by doing that, now I can write this as m minus 2 squared and negative 33. I'm going to take the square root of each side. So I have m minus 2 equals the square root of negative 33. Uh-oh, red flag. Big time red flag. I can't take the square root of a negative. But if you recall, one of the things we did this year is we talked about how I can essentially take that negative, put it out in front, and call it I. An imaginary number. If I can break down 33, I'm going to, but I can't because 33 is a prime number. Well, no, it's not prime, but its only other factors are 3 times 11. There's nothing I could break out there. So this is m minus 2 equals the positive or negative I radical 33. Add 2 to both sides. So m is equal to 2 plus or minus I radical 33. Solved by completing the square. Quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. In this case, a is 3, b is 8, c is also 8. So x equals the opposite of b, so the opposite of 8 plus or minus the square root of 8 squared minus 4 times a times c all over 2 times a. Now, I told you in class a bunch of times, I think the smartest thing to do is to take this radical, go over to the side, simplify that, and then come back to where we started and just put something in this box. So I have the square root of 8 squared is 64. Let's see here. 4 times 3 is 12. 12 times 8 is 96. So that's going to be 64 minus 96. It's a negative 32. Okay, well, let's take that negative 32, and let's break that down. First of all, I know I can put an I out in front to make that an imaginary number. 32 is 8 times 4. 4 is 2 times 2. 8 is 4 times 2, and another 2 times 2. So here I have a pair, one breaks out, one knocked off. Here I have a pair, one breaks out, one knocked off. And then I have one lonely 2 here that's left under the radical, can't break out. So I had 2 times 2 broke out, so that's 4, radical 2. Oh man, let me cut that box out. Drew the box too small. So this is x equals -8 plus or minus I times 4 radical 2 all over 6. At this point, your best bet is to take and split each part. Put each part over that denominator, because that's going to help you to reduce this better. So this is -4/3, because each of those can be divided by 2. And over here I'm going to have I, 2 radical 2 over 3. I can divide each of those by 2. Okay. Ideally, and this is the way you'll see it if this were to be a multiple choice, we're going to write this complex number as 2i radical 2. Okay. So if that looked a little funny to you before, that's probably why. And really going back to this here, we should have written that as 4i. And this down here as 2i. Okay. Solve algebraically. Well, we could do this using substitution. This will be real quick. I take this, I substitute it in place of the y. This becomes 2x equals x plus 3. Subtract x from both sides, and you get x equals 3. Take that, plug it back into either, plug it in there I guess, y equals 6, so my ordered pair that satisfies this is 3, 6.